Hey everyone, Jay here from Project Unity, and tonight I'm sitting down with two individuals who are at the forefront of the civilian effort to gather credible, actionable data on the UFO UAP phenomena by utilizing a global network of machine learning, smart cameras, and sensor arrays operating via an open source software. This was created in the hopes of stimulating the largest observational science project in history, and I'm talking about Sky-Hub. And today, I have the founder of this project, Steve McDaniel, and our mutual friend and Sky-Hub financier, Bob McGuire, on the channel for a deep dive into what Sky-Hub is trying to achieve and how they plan to achieve it. Steve McDaniel has 20 years of technical experience covering a wide range of industries. He has 17 plus years of experience within areas such as software development, reverse engineering, Windows, Linux, kernel development, and developing highly distributed systems. He has experience developing on Linux, Windows, and Mac OS X, and has several years of experience using a variety of debugging tools, profiling tools, and software assurance tools. Steve has also spent 5 years within Navy intelligence and 16 years within the National Security Agency, or NSA, and he has worked for defense contractors such as Northrop Grumman, where he spent 8 years of his career, as well as Raytheon, another one of the US government's top-tier defense contractors. Bob McGuire has a PhD in applied mathematics from Brown University. He recently retired as Chief Scientist of Hume Center for National Security and Technology at Virginia Tech in May of this year. Bob also started 2 companies, a 5G network company called Federated Wireless, which has 5G equipment deployed all over the US, and a geospatial intelligence satellite company called Hawkeye 360. Hawkeye 360 has 3 satellites in orbit, put up by SpaceX, and 3 that are currently under construction. Bob also worked for the United States intelligence community from 1986 until 2010, at which point he joined the faculty at Virginia Tech. Please remember to like and subscribe, and I hope you enjoy this talk with Steve McDaniel and Bob McGuire. Let me first of all just thank both of you for taking the time to sit down and speak with me today. Genuinely really excited to jump into this discussion with both of you. So if I could start this off maybe with you, Steve, can you just tell us what started your interest in this field and how this led to you eventually wanting to create something like Sky-Hub?
So yeah, that's a really great question. So we've all seen things we can't really explain, and that's what this is about. For me, what really kicked us off is when Lou Elizondo and Chris Mellon stepped out on stage and told us about TTSA, and the 3 DoD videos came out, and that really piqued my interest. I was kind of put in a position. I'm like, well, we have these really credible people working for the government that are saying that the UFO phenomenon is real. So, and over time, I was interested in an approach that could really shed light into what's going on, and kind of looking through like the books and the documentaries and what people are working on. Kind of the conclusion was the only way to really make progress here is through science, and observational science is the perfect methodology to use to explore this. So that's where Sky-Hub was born, was this idea of deploying cameras and sensors to collect hard data that can be shared with scientists and researchers to help make progress to shed light onto the UFO phenomenon. That's really where it started for me.
And were you interested in this field of study prior to the kind of announcements that have happened since 2017, or was this all very, very new to you?
So I would say like through my entire life, I've read a total of 2 UFO books, and sure, I used to catch the occasional documentary about UFOs, and I was always interested in that regard, but I never really made it a focus to do this consistently until 2017.
So was it specifically the New York Times article that piqued your interest at that time?
That's correct. When that article came out, and I read that, I was like, whoa, hold on. I was like, let's step back for a minute. I was just kind of wondering to myself, is this serious? Like, are these people for real? And that's what really got me interested in the topic. And of course, I went to Twitter and found that there was a UFO community on Twitter, and started exploring and meeting people
Right.
like, Joel Dodd and Bob McGuire and others that I started to work with to help build SkyHub and other, like, worked on other efforts. So yeah, that's kind of what really kicked it off for me, was the New York Times article.
Well, I think a lot of people would feel the same way because it was such a shockwave that came through the mainstream media. I don't think anyone could have predicted, even in the UFO community, that, the New York Times dropping a front page article about a Pentagon program. So I think that that's a pretty reasonable starting off point to consider looking into this. What were you doing before you got involved in this, like career wise?
So I'm a software engineer by trade. I've spent a good majority of my career doing security research and high-speed processing and dealing with big data. And I've been an embedded developer on a lot of different projects. And I've been heavily involved in that kind of work. So building an observational science platform like SkyHub is right up my alley, because it's, developing drivers for hardware and developing distributed networks with a cloud infrastructure. So uh, kind of, it was a great fit for me, and I was able to put my skills to use.
Well, we are going to jump into a deep talk about SkyHub soon, but I want to just quickly segue over to Bob, because I think it's fair to say you've become quite a well-known figure within the UFO community of late. But for those listening who are not familiar with you, could you just give us a little bit of background on your own career, your past government work, and also your reasoning for becoming what is now quite a respected voice within the UFO community?
Okay, so I want to say that Steve and me kind of becoming active were for nearly exactly the same reasons. So I heard some rumors, and then the videos and interviews and New York Times came out, and I did some research and became curious. And I'm a avid reader, note taker, etc. So I looked around and found Richard Dolan, and found that his books were well respected by people I knew in the national security apparatus of the country. And so I became a member on his member site. Then he started a forum. I became a fixture on the Richard Dolan forum. And now I'm the moderator on the Richard Dolan forum. So anyway, after late 2016 and 17, when he started the forum, he announced that he would be interviewing Christopher Bledsoe. So I heard the first two interviews for Chris Bledsoe on the Richard Dolan regular show, and I wrote Chris Bledsoe a letter. And I says, Chris, I'm a scientist at Virginia Tech. I'm been doing technical work my entire life. I know you've had other scientists visiting there, but I'm interested in coming and talking to you and see if there isn't some science we can do that might help in finding out what's going on there. The reason I was doing this is, I was interested. All this other stuff had piqued my curiosity, but Chris kept showing up with these shaky handheld cell phone videos. And I told him, after the things that I've outlined many other places that I saw when I was with Chris, I says, Chris, this ought to have all sorts of things that are detectable. First of all, we're seeing things that look like they ought to put out EM pulses. There's moving lights that we ought to be able to track. There's probably other emanations that we could detect. We want to find out whatever's going on in the environment whenever this stuff happens. So I said, look, if I could just sit down and write down a list of sensors that we ought to try to put together. I knew that video was going to be a major part of it, because that was kind of what everyone looked at, even if it was shaky and blurry and lousy. But I had zero experience and zero capability of writing video processing software, but I had done a lot of machine learning work. So Stephen, I met. Steve jumped off with Sky-Hub. My part is I'm more interested in kind of the other emanations that are going to be happening, in my opinion, around things that Steve and others who've now worked on Sky-Hub for a while are going to be tracking with video and filtering through machine learning. So my personal interests are, it's easy to look me up on Google and you'll find out that I've been doing digital signal processing and software-defined radio at a fairly high level since the late 1980s. And so my personal interest in this is if a Sky-Hub tracker is sitting near someone that has a large transmitter near them, such as an FM transmitter or television tower, they can use the signals those things already emanate into the environment, and we can see the signals coming from those things bouncing off of moving objects. So this is called passive radar, and we might be able to track the things that others can visit and see in the sky with their video. And in addition to this, I propose that we use other things that we already know how to do to eliminate those things that aren't interesting. So for years I had been doing what's called ADS-B copying, which is a radio listening to 1090 megahertz, because all commercial airplanes and most military airplanes that aren't on missions are required to emit when they're in the air.
Right,
and
right.
This is for collision avoidance, but if they're flying over your location, you can hear their emanations. So if you track an object in the sky and it's emitting ADS-B, unless the aliens are emitting ADS-B, it's an airplane and we're not interested. So that's one thing. The other thing is you're seeing all these Starlink satellites that are flying overhead. So the NORAD publishes all the orbital elements for almost everything you can track in the sky, and I want to be able to eliminate Starlink and other satellites. So between eliminating satellites and eliminating airplanes and my interest in doing tracking, it seemed like a good thing. And I've been supporting Steve and the guys doing the work on Sky-Hub for a while. So me personally, I retired in May from being chief scientist of the Hume Center for National Security and Technology, the largest funded research center at Virginia Tech. I retired in May, returned to my home state, which is Alabama, where I now have a home, and I'm doing my tinkering and fiddling around with software-defined radio and astronomy and other things. So I started 2 companies, and I'm able to retire, so I did. And I'm going to be adding these things on, and including doing machine learning work with Steve through exciting stuff we can tell you about as we go on. But that's I was a little long-winded, but that's the basic history.
Well, I appreciate the background on that, Bob. And for those that don't know, Bob and I have done talks together on different panels with people like Grant Cameron and others. And to be honest, this is something that I just asked Steve, but I don't think I've actually asked you or I've heard anyone ask you. I'm wondering when you actually specifically got interested in the UFO phenomenon from a scientific perspective, and realized it was something to take serious. Is this something that you've known for a long time, or are you the same with Steve? That it was the recent announcements that catalyzed your interest.
It was the recent announcements that got me to be interested now. But I had interesting experiences that, looking back on them, they were weird all the way back into early childhood. So just quickly, my mother tells me, because I don't have a memory, that I had 3 near-death experiences before I was 1 year old. I had cerebral meningitis, and but I recovered. At least most people think I've recovered. And at 3 years old, one day I walked out when she and her friend were having coffee together, and I quickly proved to them that somehow I had become a pretty good vocabulary reader at 3 years old with no training. And so I've had weird things happen like that to me most of my adult life, until at 19, taking my girlfriend home to our joint hometown from university. I had well over an hour of missing time, and everything I was going to do with my life, I overthrew it and became a mathematician and engineer. So that was the last kind of really weird thing that happened to me personally.
Right,
I
right.
can remember until I went and visited Chris Bledsoe, and it's been nonstop weird since.
Yeah, well, I've heard a few things, and after we've dived into SkyHub, maybe we can probe a few answers out of you in regards to your experiences over there as well. No pun intended, saying probe there, but I want to open this up for both of you as well. But Steve, if you want to just jump in first, for anyone who doesn't know specifically what SkyHub is, can you just give us a generalized breakdown of what you're trying to do here?
Yeah, of course. So really our goal is currently the state of evidence for UFOs is weak in a lot of areas. So if you go onto YouTube, we can all pull up grainy UFO videos that are shaky. Most of them are taken from cell phones. And a lot of the pictures, you can't really make out what it is. So that's we have somewhat of a data problem. The other issue is we really don't know the provenance of the data. We don't know if it's credible, or if someone is actually tampered with it, or if it's just purely CGI. So we wanted to approach this in a way where we can produce data that people can trust. And we want high fidelity video and photos. But not only that, we want to back up this data with sensor data. So it's important that we back up all the video data with GPS time and location. We want to know exactly when and where a video was taken. We want to know all the atmospheric readings, the magnetic readings. We're using gyroscopes and IMUs. So anything that we can measure about the local environment and save that data along with the video, I think will help tell a more compelling story. So there's been a lot of stories that magnetic anomalies happen with in conjunction with UFO sightings. So we have all the necessary sensors to capture that data and record it properly. Now, all of this data is aggregated on the SkyHub tracker, which is a hardware device that you can deploy at your home or at any property that has power and internet access. So it'll sit there and record 24/7, collecting all of this great data and video and aggregating this data onto the tracker and uploading it automatically to the cloud. Now, there's something very important here. We are going to share all of the data publicly. Of course, we're going to make sure we keep people's privacy kept private. So all of the GPS location data will be minimized so we don't actually publish the locations of people's trackers. But we want to be able to share this data set with the public. And more importantly, we really want to enable data scientists, and researchers, and experts in their field to come and use this data to analyze and produce studies. So we've spent a lot of time creating this infrastructure to allow trackers to collect this data and upload it to the cloud. And to date, we've got a really great science team, and currently Cogswell is the head of that scientific board, is basically corralling all the experts in a bunch of different fields that are looking into different ways to capture data, the types of sensors we should use, machine learning algorithms we can explore. So it's been very good for the project having Chris Cogswell lead that effort for us. But some of the other things is created somewhat of a DIY project that anyone can get involved. So if someone wants to deploy a SkyHub tracker, we have a great website at skyhub.org, and all of our documentation is at wiki.skyhub.org. And you can log in there, and it has all the components that you need to actually build the SkyHub tracker. And we have a chat available at chat.skyhub.org, where we have dozens and dozens of users there that will assist you setting up and building your tracker. So it's been really great. It's a very community-oriented group, and we welcome anyone to come join in and help develop or deploy a tracker or anything they want to get involved in, they can with the community. And really what it is this is a global citizen science project. And that's a great way to look at it, because we want everyone across the globe to get involved in this science project, where we're looking for truly something that a lot of people may consider fringe, but this is science, and this is a great way to get involved in a science project where you follow a specific methodology and a set of rules to try to learn more about the world that we live in.
Just let me add quickly that it's open source. You can download the source code as it's being developed from GitHub, and the hardware and how to package it and all that other stuff is open specification. This is kind of wide open, and we're not going to be amenable to or supportive of keeping stuff a secret.
Brilliant.
Another really important thing to share is that we've had a fantastic donor actually donate money to help us produce the first batch of manufactured Sky-Hub enclosures. So we're currently working on getting a manufacturer to produce prefabricated enclosures for people to purchase. We're hoping we can get that purchase price in right at around $100. And users will be able to come purchase this enclosure to help basically assemble their Sky-Hub tracker. And if you want to see a picture of that Sky-Hub enclosure, you can go to skyhub.org and see the beautiful enclosure that our hardware engineer Richard put together.
Yeah, we'll have that come up on the screen as we're mentioning it now. Is that the all white model that I've seen?
That's
beautiful.
correct.
Yeah, that looks brilliant, really modern and like kind of sleek. I've really loved that design.
Oh, it's fantastic. Richard has put a lot of time into that, and that enclosure.
Well done, Richard.
Yeah, that enclosure will house all of your cameras, all of the sensors, and all of the processing platforms required to run the tracker. So it's really a great piece of equipment that is going to be resilient to weather and water, and you'll be able to deploy that into a number of locations.
So I know it's still early days, relatively, but what's the future of Sky-Hub exactly? Are we looking at like a niche observational analysis tool for UFO hobbyists, or is this something that you intend to see being utilized on a large scale, perhaps more geared towards academic and private sectors for data collection? What's the kind of future goal for this?
So one thing that's been really important to us is that we don't want to deviate away from our core goal. Our intention is this will always be a platform for collecting data on the UAP phenomenon, and that's going to remain a core goal. But we encourage people to use Sky-Hub for all kinds of science. So if we're going to collect data on the environment and weather and other aspects of the environment, like magnetic readings, we encourage people to get involved and use it for all types of science. Sky-Hub was created about a credible scientific effort to collect data on the UFO phenomenon, but it definitely doesn't limit its use. I mean, Sky-Hub could be used for tracking bird migration. It could be used for drone detection. There's so many uses for science that we could use Sky-Hub for. So I really encourage people to get involved, even if they're not interested in UFOs, to look at the platform and see how we could use Sky-Hub to learn more about the environment.
I'm not sure how many Sky-Hubs you currently have active, so you can tell me in a second, but have you managed to collect anything from your equipment so far that you would consider to be, really quite compelling evidence of UFOs and UAP?
Yes. So we did capture some very interesting videos from Houston, Texas. Now, one of our members, Adam, has a tracker deployed. He had a tracker deployed on a high rise in Houston. And if you go to skyhub.org, we actually have the video on YouTube up there that we observed an object moving across the sky and came to a complete stop. And this was in the middle of the night. Came to a complete stop and moved and started moving in a different direction and disappeared out of the frame. So things like that, where we see non-ballistic motion, definitely raises more questions. Obviously, we don't have enough data to conclude what that was, but as we progress, we've added a lot of sensors to the platform since we took that video and improved the SkyHub tracker. But there's videos like that where we're seeing truly strange behavior in the skies, and what we really need to do is collect more data and deploy more trackers to be able to do additional calculations to understand how fast the object is moving and how large it could be. As we get more and more cameras fixed on the same object, we'll be able to drive more information and data out of those events.
Well, that leads on to my next question, actually. And by the way, if everyone listening, all of the links for SkyHub's different platforms will be in the description box below, so you can check all of this out once you're done listening. But if I wanted to purchase a SkyHub kit, can you talk me through the process? Because if I'm correct, what you provide right now is a list of items which are required to build the SkyHub, and then you also have the open source software. So how does somebody get a SkyHub kit?
So right now, this is a completely do-it-yourself effort. We've provided a list of sensors and hardware that is required to put one together. So on our wiki, we have a list of all the materials required. So you can essentially go onto Amazon and purchase all the parts. And 2 days later, you'll get all your parts. And we have a guide on the wiki that will walk you through assembling the SkyHub tracker. Now, we understand this may not be the best solution for everyone because you do have to be somewhat technical to put it together. However, we're improving the process iteratively to actually deploy a SkyHub tracker in time, especially as we get the enclosure manufactured. That will greatly simplify the process for building a tracker. And as we get more mature in our project, we could potentially have an IKEA-style kit where you just get a box of parts and you just assemble the whole thing. So as we progress, we really want to make this more accessible for the general population that doesn't want to, hook wires up and install components in a box. And, if there's any listeners out there that want to help get involved to help streamline that process, we welcome you to, jump on board and help us make this a product that we can get all over the globe.
Well, I think that would hopefully be the end goal, I guess, for you guys. It would be a very streamlined availability that someone could just buy one. So is that kind of, obviously this is a developmental process and it's going to take a lot of effort, and that's what that we want to see happen. But is the end goal to actually have a fully built by yourselves, surveillance tool that people can literally just purchase? They don't even have to assemble it. Is that something that eventually at some point down the line you want to see realized?
I think that would be a great outcome. But being a hardware supplier is a very difficult business.
Yeah.
So there's a lot of pros and cons, right? Because we do want to deploy the platform globally, and we want to make it plug and play for people. But to be a organization that actually produces a product and delivers a product to customers requires a lot of support, a lot of money, and it's one of those things that I think we can gradually work towards, and one day we may be able to realize that goal. But I think for now, it's easier to try to simplify the building process. But one day, hopefully, someone can go onto Amazon and buy a SkyHub. But I think we're a ways away from that. One thing there, and I really hope that as the community grows, perhaps community members will be willing to build SkyHubs for their friends or for people that want them. For, let's say you just want to buy a SkyHub, you might be able to find someone in the community that will build that SkyHub for you if you pay them, $50 or $100. I'm really hoping that happens within the community, where you have people that have the technical know-how to assemble the entire box that will do it for a simple fee.
Oh, there'll definitely be some handy people that will do that for people. I guarantee it, especially within the UFO community, just because there's a shared passion, and we want to see the evidence getting gathered, and then hopefully from there it will echo on into more mainstream attention, and people will want to use it for applications outside of just the UFO community, because that's what we're all trying to do, isn't it? Is break out of just the UFO community.
Definitely.
So can you guys explain how the Sky-Hub differentiates between anomalies and conventional objects like aircraft and, birds, meteor showers, etc.?
So I can talk about that a little bit, and this is something that Bob and I have been working on in the background a little bit. We've been focusing on machine learning quite a bit recently, and that's going to be kind of a very important component to Sky-Hub. So one thing I've been working on for a while is using NVIDIA DeepStream. Now, NVIDIA provides lots of great hardware for gaming and machine learning. Well, we want to leverage this hardware because the platform that we use in the tracker is an NVIDIA Jetson platform, which comes deployed with machine learning hardware and a GPU. So NVIDIA DeepStream allows us to leverage this hardware to do video processing and machine learning. So we're using machine learning models to help detect known objects. So it's important for us to detect known objects like birds and planes and helicopters because it helps us filter out the things that we know about. And we can use anomaly detection to help identify things that are harder to detect or truly unknown. So this actually helps save a lot of human hours if we can just say, okay, that's a bird or a butterfly. And, we don't have to manually spend time trying to figure out everything that's triggering an event in the tracker. We can help filter those things out. And Bob briefly touched on this before. He's a signals guy, but he's got a lot of experience with ADS-B, and it's a really great technology that allows us to identify what airplanes and aircraft are in the local area. So we can use that technology to help filter out airplanes and helicopters and other aircraft that are broadcasting on the ADS-B signal. So those are really great basically filters that we can use to eliminate known objects. And
I want to add that. So I have had several graduate students who have now gone on to apply, and in some cases started companies that take machine learning algorithms, listen to signals with software-defined radio equipment, and does things with the machine learning processing on these signals. So let me give you an example. The Army paid me and my students to develop a machine learning based detector that would detect frequency hopping radios that might be used by an adversary to the Army. So that's a specific application of machine learning to a particular type of radio. The thing that Steve and I know, and what we're attempting to do, is you can take older trained models from things like video, looking for things that are moving, or signals that you're detecting that might have certain characteristics, and you can generalize them to do new things that are different from what they did before, including emitting pulses that are happening, say, when the quote UFO comes through a portal and it emits an electromagnetic pulse, or it moves rapidly through the air. And if it does a really strong non-ballistic turn, the radar returns will have weird signatures. So we want the machine learning to look for these weird signatures in radar, and we want the machine learning to look for weird and different things in the video. And amongst all these things put together, we want to do sensor fusion, so that we take all these different sensors and we let them work together to filter out stuff we don't care about and point out those things we do. And so we've got all of this fancy machine hardware that people outside of government rarely do these kinds of things, where you do all these sensor fusions, because it's always been way too expensive. So only the military and the intelligence communities of nation states have done it before. But Steve and I knew something, and we still know something. The thing we know is that the cost of technology and the way it's being deployed is plummeting, just falling through the floor. And let me give a specific example. Steve and I both are on the waiting list to get an NVIDIA ARM plus GPU. That's as cheap as a Raspberry Pi. It's $59. And we're going to be able to deploy. We won't be able to train, but we'll be able to deploy our sensing software for various types of signals and other types of processing on this NVIDIA Nano with 2 gigabytes of memory and a GPU. And $59, it replaces equipment that 10 years ago would have cost $1 million. So the cost of technology is plummeting. The technology we have is software reconfigurable and reprogrammable, and it's easy to change programs as we learn more. So as we get all of this data going into the cloud that Steve is telling you about, we won't sit on our laurels. We'll be constantly using that data to improve our detection capabilities.
So you're saying really that because of this decrease in the price of technology and the kind of technology that we can get access to as civilians now, that we're basically being able to do things that have for a very long time only been restricted to governments and intelligence services.
Precisely.
So
And Steve and I came from that world. Steve did, and I did. We both came from the world of doing stuff for government that cost a lot of money, and the cost has fallen through the floor.
And the thing that's great is a lot of the technology and algorithms that are actually being applied today for machine learning were actually heavily researched in the 80s and 90s. And things like neural networks were heavily researched in an academic environment. However, hardware wasn't good enough to actually train neural nets. So, there was processing limitations, there was memory limitations. But today, where GPUs have gotten so much better, processors and memory has gotten so much larger, we can actually train really large neural network models and machine learning models that we can use on small devices. So it really is technology finally catching up to research that happened in the 80s and 90s. And the entire machine learning field has exploded over the last 10 years with tons of new capabilities and algorithms. So that's really, we're taking advantage of lots of research and development that has been done over the last 20 years. And especially, companies like NVIDIA and Google and products like TensorFlow has enabled us to make use of these technologies on small edge AI devices.
And every bit of this software, this DeepStream and this TensorFlow and all this stuff is open source. I mean, you can go and look and see how it was written and how it works. And as Steve said, I recall the last time I looked at and rejected using neural networks. I ran this software-defined radio project for the United States government at the Institute for Defense Analysis in Princeton, New Jersey. And we had all these people that wrote all these neural network-based algorithms, and we were running them on very large Cray supercomputers. And I went, this stuff is just not ready. And it was at that year, which was 2008, that Hinton first came out with the MNIST Vision database work using GPUs to do the computation. So I rejected them just as the technology exploded, and Geoffrey Hinton told the world how to train these things very, very quickly using GPUs. And from 2008 to 2010 or 11, the world totally changed, and the price of hardware has just gone through the floor.
Now, you guys might have to put your training wheels on just a little bit for me here. Can you explain to a layman like myself what exactly machine learning is and how it's going to be utilized in respects to something like Sky-Hub in particular?
So, like at a very elementary level, it's basically just statistics, right? So it's basically a process in which, like, you have a picture in front of you. The algorithm is going to look at that picture and extract features out of that picture. And then it's going to run through a series of mathematical calculations that tries to determine what's in that picture. So there might be a plane in the picture, and with the features that were extracted in that image, it'll run through a bunch of basically a statistical process to determine what the likelihood of a plane being in that picture is. So when you run a picture of a plane through a neural network, the output of that neural network is going to be a probability of what it thinks it is. So
Right.
it'll say, the output might be, there's an 82% probability this is an airplane. So that's essentially what it is. It's a process in which it's purely statistical, based on the vectors that are fed into the neural network.
So, am I correct in saying, and this is probably very basic, but at least to some extent with Sky-Hub, do you feed it a lot of data beforehand in regards to conventional things so that it learns quickly what's a plane, what's a bird, what's a meteor, and then it can quite quickly differentiate between what's anomalous and conventional?
So it's really hard. So I know, like, at some point, like, publicly, people have had criticism like, oh, Sky-Hub's going to make a UFO detector. That's not really what we're doing. We understand that we need to identify and filter the things that we know are natural and things that we know exist, like airplanes and drones. And then we can focus on the truly anomalous things, right? But really, how you do machine learning is you do have to train a machine learning model off a labeled data set. And what that means is a human has to actually go and say, there's an airplane in this picture or there's a bird in this picture. So you need a mountain of data, like literally thousands or millions of samples of data that's labeled by a human,
Right.
to train a model that can automatically detect. So yes, and the great benefit with that is you have Google and Amazon and Facebook and Kaggle, where you have data scientists that have provided free data sets to the public to help train machine learning models. And Bob mentioned MNIST, which is a great machine learning data set that can be used to automatically detect handwritten words, and it can translate it automatically using a machine learning model. So fortunately, there's been thousands and thousands of researchers that have published this data for free that we can start with. So we don't have to start from scratch. We get to start with work that thousands of people have collaborated on. So we actually have a great head start because the community has been very good about sharing research in the machine learning field.
Exactly. And what we'll do is take what's already been done and generalize it or improve upon it for our own work.
On the Sky-Hub website, a link, by the way, again, for everyone listening, is going to be in the description box below. It says on the website that we are creating a crowdsourced network of smart trackers that will each recognize with edge processing whether an anomalous event has occurred, and that will each automatically upload the anomalous data to the Sky-Hub cloud. What is a network of smart trackers, and what is edge processing?
So edge processing is a common term. So it's basically edge AI. So that's become a very popular term in IoT. So IoT is the Internet of Things. The most common IoT device is currently security cameras. So think of your Nest camera or your Ring doorbell. Those are IoT devices. So when we talk about edge AI, we're talking about machine learning that is done at the edge, and the edge in this case is the Sky-Hub tracker. So we do that.
You had one like the Blink cameras that people put around their houses that detect motion and then send the video to the cloud.
Right,
that is almost exactly what Sky-Hub is doing.
Yes, correct. So we're using edge analytics to help limit how much data we have to send to the cloud, because we don't necessarily want pictures of butterflies from all over the globe.
Right. Okay.
That's a lot of data. So if we're uploading a video every time something moves in front of the camera, we're going to use a lot of space in the cloud. So we can't necessarily do that. So it's important to apply machine learning techniques at the edge to help filter out known objects and try to capture only unknown things. So
let me give you an example. Half the video that my Blink cameras record are limbs moving in 15-mile-an-hour winds. We cannot afford to pay for the cloud storage, which is not free, by uploading tons of limbs moving.
And that's where machine learning is really of value. So instead of having a human review every video and every bird or tree limb or cloud, we can use machine learning to actually filter out those things so a human doesn't actually have to look at it. So it saves us time and it saves us space and helps us narrow down looking at truly anomalous things. So our approach at SkyHub is to use kind of a cascading filter where we have a number of filters to help filter out known objects. So we're looking at different algorithms to help determine anomalous objects in the picture, like non-ballistic motion, or doing tracking of optical flow vectors in pictures. And I don't want to get too much into the weeds here, but we're looking for truly anomalous motion, like motion in videos, or if there's nothing anomalous in the video stream, but the sensor array deployed in the SkyHub tracker observes like an anomalous magnetic event, it'll trigger recording video automatically. So maybe the camera didn't catch something, but the other sensors are observing something strange. So we'll automatically record from every sensor and upload that to the cloud.
So a sensor that's commonly found in your cell phone and other things are accelerometers and inertial management units. Now, those are fancy words for somebody made it move faster or change direction. So if an anomalous object is manipulating the gravitational field around it in order to move, these things that are accelerometers or inertial management units might be able to detect them. And so if we find an anomaly in the acceleration or orientation of our sensor, even though we know it hasn't moved, that's something we want to trigger a video recording and every other kind of data on almost immediately.
So what kind of sensors are we talking about here in regards to, what spectrums are you actually looking at?
So we've actually spent a fair amount of time on sensors. So we have an inertial measurement unit, and Bob briefly just talked on this, and that's essentially a gyroscope, and it measures like pitch, attitude, and roll. We're measuring barometric pressure, temperature, humidity. We have a lightning detector. We also have a geophone, and a geophone is a sensor that measures 10 hertz to 240 hertz. And it's generally used to measure seismic activity. So it'll actually pick up very low frequency emanations from the earth. And it'll record that, and the tracker will capture that data as well. We have multiple gyroscopes and magnetometers, and we have a thermocouple for temperature. And we have a UV sensor as well as a light sensor that cover slightly different light spectrums. And some of the things in regards to passive radar, we can let Bob touch on some of those items to cover the different spectrums there.
Yeah, so people can go look up Kerberos software-defined radio, Kerberos SDR. Lots of people that have done software-defined radio or tinker with radios are familiar with RTL SDRs, which are these USB dongles you plug into your computer on one side and stick an antenna on the other side, and all of a sudden you can listen to airplanes, you can listen to the FM local radio station, you can listen to the local police and fire chiefs and so forth, but with one radio dongle. So a group of people that are trying to do some really interesting work put together 4 of these things in a single box, and then figured out a way to make them sing together perfectly. I did put it that way because what they're actually doing is arranging for the processing to be coherent. But they've done it in a really neat way. Okay, so once you have these 4 receivers working together, you can hook them to 4 antennas. And looking with the 4 antennas at the radio beams that are coming through the air, you can hear a loud radio station, and you can also hear the weak reflections of the radio station signal off things that are flying overhead. So, as you can imagine, the path from the radio station to you and the path from the radio station to the moving object reflected back to you are take different lengths of time to get there. And using this different lengths of time for the same signal to reach you, you can make mathematical calculations that tell you where the thing is in the sky and how fast it is moving. So this is how you do radar using somebody else's signal. And so we would really want to perfect that, because we want to provide ironclad proof that material objects are moving through the sky, especially if we can figure out that we can detect when they do anomalous types of motion through the sky. Because if we have actual radar data showing anomalous motion, no one will be able to deny it.
Yeah, this isn't just a night vision fisheye camera, basically.
The nice thing is these fisheye cameras, like the one that was deployed in Houston, they have IR capability. And I think this thing that was caught by our friend Adam probably was emanating in the IR more than it was the visible, and this camera caught it.
And one really important thing to this whole effort isn't just to take fancy pictures of unknown objects. This is really about creating a comprehensive data set that can be used by the academic community to do hard research into the UFO phenomenon. Really, one of our goals is to bring this into mainstream science. And we're not all about speculating. We don't have any preconceived notions or biases. We just want to collect data and follow the data. And the best way to do that is to collect as many data points as possible, be clear and transparent about how you're doing it, and share that data with the world, and allow people to analyze that data. Because I'm not an expert in physics, and I'm not a mathematician, and I'm not an expert data scientist. But our hope is that we can aggregate this data, and those experts will come and share their insight and analyze that data.
Absolutely. I think collaboration, wider and wider collaboration with the academic community is absolutely necessary, which actually kind of segues into what I wanted to bring up next, because Sky-Hub was mentioned in MJ Banias's article on Vice titled "The Subtle Art of Tracking UFOs." That was alongside Hypergiant Industries. Now, the owner of Hypergiant, Ben Lamb, he was quoted in another article to have said, if you look at the intersections of Hypergiant's three main interests, UAPs are the X at the cross center. And in this article by MJ, which includes Sky-Hub, Ben Lamb was also quoted again, and this time he said that right now we know there are UAP. We have multiple videos that have been validated by both our military and leading and established news outlets. There is no reason not to leverage AI and data. We have to try and solve these questions. So real quick, has there been any discourse between specifically Ben Lamb and yourself in regards to similar goals with AI and UFO tracking?
I have not personally spoken with Ben Lamb, but I would definitely love the opportunity to work with Ben and collaborate with Hypergiant. I think that would be, we could definitely make a lot of progress. We can work on a lot of similar goals and potentially help push the effort along. So yeah, I would definitely welcome that conversation.
And so would I. And my only concern, and just let's get it out up front, is Hypergiant is in the business of trying to sell their services to the government, and
Yes.
Sky-Hub is not in the business of keeping data private. So if we got past the obvious tensions and figure out a way to work together that serves both of our respective people, users, friends, etc., without stepping on each other's toes, I guarantee you Steve and I and Chris and everybody else involved would jump right in.
And that's important, because I can't emphasize enough that this has always been about transparency and openness. Like, and Bob mentioned, all of the code that I've written and that Corey has written is free for the public. Like we've made all of our code available under a very liberal open source license, and people can take the code and modify it and add to it. And we hope people get involved and help us develop this. But the data that we produce with Skyhub is also under a Creative Commons license. And we made a decision early on that we didn't want this data to be commercialized. So we put this under a Creative Commons license that does not allow commercial use. And we want to keep it that way. We're not here to make money. We're here to find answers and do science. So any relationship that we develop with the community or with the private sector, we want to maintain that transparency and stick to our core goal. And I think that's really important for Skyhub.
You know, I've said this before. It seems as if Skyhub's going to maybe overtake the Scout initiative put forward by To the Stars Academy. To me, it sounds like you're doing a very similar thing, but you've actually made forward progress in bringing it to the public, whereas, you know, all we've heard from them is announcements. Do you know if the Scout system shares any major similarities or differences to the Skyhub system? And why do you guys think it's taking TTSA so long to roll out their own UFO tracking tool?
That's a really difficult question for me to answer because I really don't have insight into the capability of Scout or the inner workings of TTSA. I may not be the best person to answer that question. And
the only thing I would add is you've already mentioned what appears to me, though I am not completely certain. I've seen this writing and some things said in public that imply Hypergiant is involved in their effort. So
I haven't come across that.
Yeah, so I'll try to dig that up and get it to you, Jay, because that would be really interesting. But I believe they're involved in writing the code that's going on in the background for Scout, etc.
Okay, well, that is interesting. Yeah, if you can find anything on that, I'd really appreciate you sending that over to me, Bob. So can you explain? We have gone over this a little bit, but I think, well, for me personally, I definitely appreciate a bit of a refresher on the purpose of this, and I think some of my listeners might as well. Can you explain the functions of your open source software? What role does the software play specifically as a component of the Skyhub?
So essentially, the software is what is driving the whole platform. So the software is what is executing all the machine learning models. It's what's responsible for collecting all of the data for the sensors, and it also connects all the hardware to the cloud component of the architecture. So really, the software is the brains of the operation. It makes up the user interface. We provide the ability to get onto the network and essentially turn this into a global network. So if there's developers out there, if you're a Go developer or a C developer, or you like JavaScript development, hey, jump onto the team. We've got work for you to do.
that and I want to emphasize, like Richard is in Europe, and one of the guys working with me is on the radar stuff, is also involved with Madar, and he's in France. This is an international effort, and part of the way we are kind of making sure that we never run into any kind of problems and keep it able to be open everywhere is this doing it in open source and out in the open, because we always want to be able to work with anyone in the world who can help.
Well, speaking with working with people around the world, Skyhub's got a few partnerships, including SCU, which is a scientific coalition, for UAP studies, and the UAP Pattern Detection Expedition, which is known as UAPX. How did you guys end up in partnership with these groups, and what's the nature of these partnerships exactly?
So I think one of our first relationships was with the SCU, and I think it's really important to get involved in the SCU because they're really focused on tackling this topic scientifically. And what SCU provides is lots of scientists and experts in different fields. And really, if you want to understand something, you need lots of opinions, and you need lots of experts spread across so many fields, because we really truly don't know what we're dealing with. So you want to leverage as much expertise as possible. And I think the SCU provides that for us. So it's a resource that Sky-Hub can reach out to them, and we can get access to all these experts. And on the flip side, SCU can come to us and they can ask us for things, which, it's a great relationship to be in. So they're a very important organization to be a part of.
Apart from the TTSA Scout initiative and obviously Sky-Hub as well, do you know of any other ventures within the private sector that are looking to do similar things in regards to tracking UFOs?
I am aware of a couple. So there's one called UFO Data.
Christopher Mellon was involved in that, wasn't he?
Yes, he was. He was involved with that at one point, if I understand correctly. But I actually reached out to them a couple years ago. So after the 2017 article came out, I actually reached out to UFO Data to see if I could get involved. On 2 different occasions, I reached out to them, and I never got a response from them. So I know that they've made periodic updates, not often, and I really don't know the status of their project. And I'm aware of another one called UFO DAP. That one is a product that you can purchase that appears to be closed source, costs money. It doesn't appear that they have any public mechanism to publish data, but those are the two I'm aware of, and they seem to have a decent platform, but they didn't seem to put much focus on transparency and publishing data to the public, which I think is really important for this topic. You have to be transparent. You have to publish data. I really think that's what's going to move things forward.
And at least one of them, and I'm not going to say which, was involved in a television show and spoke openly about wanting to recover the investment they had made in this hardware and software. So that's kind of anathema to us. We're not interested in flowing money through our hands or pockets. We want money to go into the project, and we're doing open source software and open specification software and hardware. It's just we just don't want to get involved in this as a business.
Right, I got you. And speaking of money going into the project and not, you guys directly profiting, but letting this thing grow, you may have already gone through this kind of stage, but do you have any crowdfunding opportunities for people who want to invest or help Sky-Hub grow, like any way in which people can support these efforts directly?
Yeah, we have a Patreon. If you want to come pledge a monthly donation to help us build and support our cloud infrastructure and do research into more sensors, you can come be a Patreon subscriber. If you just want to make a one-time donation, you can come donate to our PayPal. But yeah, if you want to help build the network or contribute, just jump to our website, and we have links to our PayPal and our Patreon, and you can help build Sky-Hub to be a bigger network.
Slightly controversial topic, I suppose, in some ways, after everything that we've been going through, which is, on the more technical side, but I would like to gauge your thoughts on this, and this is for both of you, on the concept of initiating a form of contact with the phenomenon, where a visual performance of some description is exhibited and could be recorded and analyzed, but the prerequisite for that contact was the expansion of consciousness to some form of non-local state. First of all, do you both see any validity in this concept of non-local communications? And if so, do you feel Sky-Hub could act as the surveillance tool for such contacts?
So I'm familiar with the concept. So I think one really important thing about the success of Sky-Hub is we've had a very narrow scope, and we've really strived to stick to observational science. So one of our core goals has been not to introduce any signals into the local environment with the tracker. So we are just there to observe. So as far as initiating contact or broadcasting or doing anything that would change the environment that we're observing, we've avoided. So we have been purely observational in that regard.
an early proposal which led to some internal dissension was, why don't we point a green laser where we see things moving? And we went, oh no, we're not about to accidentally point a green laser at
Right, right.
the cockpit of an airplane. So if you as an individual want to flash a laser at the night sky, great. But anything that kind of emanates from Skyhub that tries to stir things up is just anathema. So look, if you as a person are trying to do CE5 and you want to have this thing sit there without you touching it and gather data about what you're doing, it will do that. And so I'll just give you an example. Melinda Leslie wants a Skyhub out near her, so when she takes people out in Sedona and does whatever it is she does that has these people entertained, Skyhub records it. She won't hit a button that says, okay, Skyhub, I've stirred it up, go grab it. But if she does stir something up and Skyhub detects it, it will record it. So to the extent it's something aside you, not actually directed by you, but recording those things that you are able to stir up by whatever stimulus you do, I don't see a thing wrong with that, and that I encourage it. So, I'm hoping Chris Bledsoe will take this stuff and stir everything in the world up, and without any input from him, record stuff.
Well, this is the reason why I asked it. I mean, obviously, I do understand it's a bit of a controversial topic. And Steve, I don't know how much you know about my own channel and my reasons for kind of starting Project Unity, but I have had some pretty, intense experiences of my own, which I can't really discount the idea of it being because of some form of non-local interaction with consciousness. So I think for me personally, I would love to be able to, because I can't directly prove that, I would love to be able to, have a way of gathering evidence. And I think that it could actually, it could prove to be two birds, one stone, really, if we can prove that this type of contact is actionable, repeatable, and we can actually get evidence for it. So that's kind of why I wanted to jump into that. But something that I wanted to ask both of you as well, which isn't directly related to Skyhub, what do you both feel are some of the biggest hurdles we have in front of us when it comes to addressing just the UFO issue in general on a global scale with high-level engagement from, multiple sectors? We have seen a major shift, but what are the primary concerns you two have when it comes to the wider world treating this, the level of seriousness that we feel it deserves?
So I guess I can jump in here. I'll go first. So it's interesting because the UFO topic is what I like to call a dumpster fire. So many things have been included into ufology, and there's so many beliefs involved in ufology. The problem that we have is that we don't have great evidence. Now, I think there's compelling evidence. Now, if you look at the 3 videos that the DoD released, I think that evidence right there is enough evidence to warrant further scientific inquiry into the UFO phenomenon. But I don't think it's proof of UFOs. And I think we should draw a very fine line between the distinction between evidence and proof. I think that is very good evidence. And I think we should explore this. But we have to be diligent and we have to be skeptical and methodic about what we use along the way to come to our conclusions. I hold the opinion that we don't currently have enough data to come to a conclusion, and hopefully Skyhub can help in changing that. But I think it's going to take a community effort. The one great thing about science is that you don't have to be a scientist to use the scientific method. We can all approach this with healthy scientific skepticism, and I think that would help the community as a whole. So I think one barrier we have to get over is when we do produce something that is very credible and very strong evidence, the mainstream community is going to come to the UFO community and look at everything that we have. And it's going to be difficult to overcome that because, We have Bigfoot and the Skinwalker Ranch stories, and we have abductions, and we have cattle mutilations, and we have all these things involved in the topic that some is going to have better evidence than others, but mainstream scientists may look at that and be turned off by some of those things. So collectively, we're going to have to overcome those issues with really solid evidence.
I want to support Steve. We got to get past the giggle factor and get to the point where people say, okay, these people are now collecting real data that somebody can do something with.
Well, I think I would echo both of your opinions here. I mean, especially in regards to the giggle factor. I don't know if I'm just extrapolating this too far, but I do think that one of the big issues is that we're dealing with a lot of bias, and I think it's fair to say some level of professional ignorance from academics, politicians, journalists alike, which it could be postured, I think, by the fear of being an outlier. By that, I mean that many within these sectors do not feel that they can approach the UFO subject or its facets in regards to novel energy, propulsion, material science, etc., without ridicule. I think that this is one of the pressing issues, that people are afraid to be bold and to step out of the box because their peers may ridicule them. And, then there are those who actually stimulate this fear within those people. And I'm now talking about people who have no interest whatsoever in the subject, but by doing so actually prevent meaningful study from taking place due to the impact their opinion has on their colleagues. I'm thinking about potential influencers in, these aforementioned sectors who prescribe to certain bias, certain scientific, or perhaps even in some cases, which we heard Lou Elizondo talk about when it came to discussions within the Pentagon, some theological dogmas, that reinforcement of which requires a dismissal of the emerging data. And so they quite simply ignore the emerging data. This to me is a real challenge we face when it comes to raising the level of importance of the UFO issue on the global stage. It's the people within high levels of academia, journalism, politics, that don't even want to try and learn about these issues because the very act of doing so would cause them to challenge their own belief systems. I think, to cut this off, we're dealing with a wide variety of belief systems, and this spans to science as well as religion. And although we're beginning to see this shift, take place, a conversation is beginning to happen, I fear that there are still too many people, intelligent people, mind you, I'm not discounting their intelligence, but who are nevertheless having their heads planted in the sand when it comes to the UFO issue.
I totally agree. And what we want to do is provide objective data that nobody with any reasonableness to them will claim that we faked. So they have to address the data, not the people who got it.
And I think one important thing here is, like, some of the common names thrown out here are like Mick West is a perfect example, and Neil deGrasse Tyson and Seth Shostak. But at the end of the day, and we'll talk about all three of them briefly, Mick West, he's not wrong. Sometimes I think in his approach he can double down a little hard and be abrasive, but when it comes down to it, fundamentally, Mick isn't wrong. He's not necessarily right, but he's not wrong. But if the UFO community were to confront Mick West with credible evidence, if Mick is really a true skeptic, he will evaluate that evidence. And if it's good, Mick could be the community's biggest advocate, right? But what he needs is real credible evidence. When we propose these ideas, an idea that can't stand up to scrutiny is an idea not worth holding. So that's the perspective I always take. So we need to present evidence and data that can stand up to scrutiny, and that's really the way that we're going to break into mainstream science. If Neil deGrasse Tyson and Seth Shostak are truly real scientists, which I believe they are, if you present them with this data, they are really going to look at this. So if we produce that data, the scientific will flood into the community looking and researching.
What's your take on this? Because obviously, I know that, as you were literally just saying, that as an objective scientist, you do need to have a sufficient amount of data, especially as well if you're in the mainstream like Seth or Neil deGrasse Tyson. But even still, I find their lack of interest quite weird. Because these people have actually made a few comments, Neil deGrasse Tyson and Seth quite specifically, since some of the more recent news has come out again since around 2017. There's been a few different interviews that they've appeared on, or different webcam statements that they've given, and they've been quite, if not anti this, almost I don't know, like neutral, like a lack of interest, and I just find that quite strange.
Well, I can sort of understand it. Seth has literally spent his career looking for extraterrestrial intelligence among the stars. This is a academic that is devoted to doing this. I'm sure it's important to be skeptical in essentially everything you do, and I have to somewhat agree with Seth. Like, some of the evidence that we produce in the UFO community is not great. We need to get better about the evidence that we are providing to support the UFO phenomenon. And I think that's really important. And I'll reiterate, if we provide that evidence as a community, we can change that narrative. And if you actually provide these individuals and these scientists that we consider debunkers or people that are haters of the UFO community, if we actually produce this real credible data, if it exists, they'll take it serious. I'm very confident if we approach the scientific community with credible evidence that's actionable, they will get involved.
I want to agree with it. And just in particular for your audience, I want to point out that science is not opposed to dealing with consciousness, and in fact, in the past 30 days, there's been a field theory of consciousness proposed, and actual mathematical description of how the field theory will work. And the nice part of this is it allows one to construct experiments, that can be done in the lab. I just want to point out that it's called Integrating Information in the Brain's EM Field. The CEMI Field Theory of Consciousness was published in the Neuroscience of Consciousness, which is a refereed, peer-reviewed journal. So work in neuroscience and consciousness is now proceeding into things that can have non-local phenomenon in them. And this paper is being taken seriously, and it's going to allow actual experiments to be done. And we know from quantum mechanics that interactions with the force-carrying particle, photons, and electromagnetic fields can be non-local, because if two photons came from one quantum mechanical deal, they're entangled with high probability, and doesn't matter how far apart they are, if the consciousness induces an action on in an EM field, and thus the entangled photon does something that's observed, the photon across the universe will also be impacted. So if this real mathematical theory of consciousness turns out to be real, we now have a mechanism for talking about the non-locality. So I just think things are happening. We need to understand that scientists are skeptical. They argue and attack each other with real tongs and forks until they get enough proof to convince them. So it's just the way science works.
Well, thanks for that, Bob. I appreciate you bringing that particular study as well to my attention. I'm going to make sure that's linked in the description box for anyone who wants to click and have a look into that. Because this is the thing, I'm not a scientist, so I have to be careful with how I word things. I've learned a lot from what I would call an intuitive sense, and I've got a logical side to me and an analytical side to me. But it seems, from personal experiences as well, it seems to me that there is absolutely some form of universal medium within which awareness is embedded or entangled, that there is a universal substrate, essentially, that this is either comprised of consciousness or that consciousness arose from this substrate as some sort of unfathomably complex expression. But I I have to, like I said, I have to be careful with how I go into this because I can't back myself up by talking to science. I've just tried to understand this as best I can, mainly and pretty much primarily because I had unexplainable experiences, which seem to only be explainable through non-local consciousness.
Well, I just want to say that if this kind of electromagnetic field version of consciousness turns out to be a partial or whole description of the workings of consciousness in human beings, it's already not constrained to the human brain, because anything that interacts with the electromagnetic fields and influences the electromagnetic fields that are generated by or sensed by the brain is going to interact with it. So I just think this is an amazing thing, and people should pay attention to it. And I'm a skeptic over a lot of things, but once I'm shown a proof, a way to think, and I can write down my own experiments and do them, I'm happy to accept it. And look, I was a skeptic about everything I heard about Chris Bledsoe until I went and stood right next to him and witnessed stuff with my own eyes.
How are you guys doing now for time? Because we can wrap up soon, or if Bob, if you wanted to, jump into anything about Chris Bledsoe, how are you guys doing for time?
I need to leave in 13 minutes.
Ah, right. Well, in that case, is there anything else that you guys want to go through before we wrap up here?
Yeah, I'd like to throw a couple more shouts out to SkyHub. For everybody out there that's interested in getting involved in SkyHub and helping us build a data set to help bring the topic mainstream and learn more about the UFO phenomenon. If you're a developer or just an enthusiast or you just want to donate money, jump over to skyhub.org and help build the community. We've got a lot of great people involved. We've got people from Austria and America, France, the UK. We've got folks in Ireland. It's really been great to see these people come together and help build this platform. So we're always looking for more experts and enthusiasts to get involved and help move this forward. So I would say come be a part of the community and get your tracker running.
And Chris Cogswell has done a great job of setting up the Science Advisory Board, and he and the team have gone out and made working relationships official with SCU, which is a very large group of scientists, engineers, and other people that are interested in the phenomenon. And I'm expecting to see all sorts of work come out of SkyHub, using SkyHub data that winds up in SCU publications. So scientists, engineers, people that want to code, people that want to donate money, SkyHub needs you.
And with that, I just want to thank you both for taking the time to come on here and speak with me about SkyHub. I think that this is an incredibly worthwhile endeavor when it comes to adding more tools onto the belts of people who want to get as much data as possible on the phenomenon. I hope that your efforts will spark further interest within mainstream academia, because we need more scientists on board who are willing to, take a measured approach to this issue. It is in the interest of humanity as a species, really, to learn as much as possible about our reality, and UFOs are a part of that reality, it would seem. So, that's, at least to me, that seems to be very, very apparent, and people are going to need to accept that and begin taking the appropriate steps required in order to understand the phenomenon. And so once again, thank you to both of you for being two individuals who are a part of the process of taking those steps forward.
Thank you for having me on. I greatly appreciate it.
Jay, it was a lot of fun. It's always great to talk to you.